Yeah, go ahead.
Good afternoon, everyone. I'm Megha Nagabhushan. The topic I've selected for presenting today is deep learning. So deep learning is one of the machine learning technologies. So what's machine learning? Machine learning is making the machine learn by itself. That is self-teaching the machine. So actually deep learning is a successor of another machine learning technology called neural networks. So I'm going to talk about how neural network works and the disadvantages of neural networks and how deep learning came into picture. Okay, if you see this image, for a human brain it's very easy to recognize. It's a collection of handwritten digits. It's 504192. But for a computer it's very difficult to understand because it's handwritten. And in brain we have very intelligent cells called neurons. So the idea of neural networks is to make a model or a system that works like a human brain. So for that reason, this research actually started at Stanford University. So what they did was they collected thousands of handwritten digits and they divided the digits into two called the training data and the testing data. So the training data is like 80% of the data was made training and the 20% was made testing. So for all the training data, they labeled it, they called it 0, 4, 1, 9, 2 and so on. And this was fed into the computer and the computer was made to understand this or was made to learn this. Again, that was machine learning. And then whatever the computer learned out of this training data was given to the testing, was applied on the testing data, and the model was supposed to predict the data on the testing data, and the accuracy was pretty good. And this model was published in 2009. But there's also an advantage of neural networks. What neural network, suppose if I have a huge amount of images, like I have images of elephants and human and chairs and cars or something like that, and if I feed in all this information, what neural network is going to do is it's going to see, okay, if it's a human face, it should be hair, eyes, nose and mouth. If these are not there, then it's not a human face. That's how neural network works. What if the person is bald? Or what if a part of the face is chopped off, or what if there is no eyebrow? I know it's kind of illegal in a few countries. So in such cases, neural network will not give us the accurate results. It gives wrong results. It says, oh, this is not a human face. So for that reason, deep neural networks, or otherwise called deep learning, came into picture. What they do in here is, for every feature, it is decomposed into sub-features. For example, eye. Eye has eyebrow, eyelash, eyelid, and eyeball. So even if there is no eyebrow, it still says it's an eye because we give something called as computational weights. So based on the weights, it is going to decide, okay, it's still an eye, even though there is no eyes and eyeball and all that. So it has got many layers. So each layer, each feature has been decomposed and the output of one layer is given as an input to another layer. That's how deep learning works. So even if there is no hair, we say, okay, there are no weight. The weightage given for the hair is only 2. So even if it is not there, it's going to say it's a human face. That's how deep neural network works. Sorry. Alright. This is an example of deep neural network where we're giving a lot of images here. Each image pixel is counted and it comes up with the features and then the object parts. Here if you can see eyes, nose, here everything is predicted and then it comes up with something called as models, and these models is what it uses to give the predictions for the test data. This is another example where they're using faces, cars, elephants and chains. It's the same thing where they come up with different models, and using these models they predict the test data and come up with accuracy. And this is how the control flows. It starts from the image with layer 1 detecting small features, layer 2 a little bigger pictures, and layer 3 the whole thing, and comes up with the prediction. Okay, since deep learning has made a lot of progress, Google started 2 projects in the year 2012, and now they have more than 1,000 projects, deep learning projects going on in Gmail, YouTube, and even self-driving cars and all that. So this is it's a very steep growth. These are the popular applications of deep learning. The first one is called the German traffic sign, where they collected the pictures of the traffic signals all over Germany and they trained it and then they applied it on test data, and the accuracy was 99.5%, which is pretty high. And then this is house number recognition. This project was taken up by Google in 2012, and they collected the house numbers using the Street View, Google Street View application, and they came up with a lot of images, and then they tested that on their model, and then the accuracy was 97.8%. Yeah. Since you can see the performance is very high, it is not only used in computer vision, this is the example I gave you, but it's also used in speech recognition, and I'm also working on a project called call graphs, where I'm going to take one project and I'm going to make the machine learn about it and bring up the results of what the project is actually doing. So this is one of the deep learning projects I'm working on right now. And then the cons. For all these computations, it's not the CPU. We use GPU, graphic processing units, because we have very rapid calculations to do, and it is very expensive. GPU is very expensive. Okay, and then yeah, if you want your model to be accurate, higher is your training data, higher is the accuracy of the model. So that's the cons. Thank you.
Okay, questions from the panel?
So, go ahead.
You were talking about machine learning, and
Right.
what exactly is machine learning?
Machine learning is making the machine learn on its own. Like you train the machine to learn on its own. So when you give these, as I told you in one of the examples where there were digits, you're going to label this digit, and the machine is going to understand, okay, even if it's written like this, it's still a 4. Even if it's written like this, it's still a 1 kind of thing. So that's machine learning.
Other questions?
So a neural network has one hidden layer,
Yes.
and a deep learning neural network has 2 hidden layers.
It can be 2 or more than that, depending on the model,
I see.
depending on the project.
So more layers is better.
More layers is better because the accuracy is high.
So why
It
would
gets
I?
deep into the details.
Should I have 1,000 layers?
No. I don't think any model, they've come up with any model with 1,000 layers. I think the highest is 17 layers.
All right, thank you.